Hi guys, and welcome to today's video on calculating the correlation coefficient. It's really good to see you here. Welcome, welcome, welcome. Now, in our previous video, if you remember, we looked at the idea of Pearson's correlation coefficient, which is basically a numerical value, and I am reading this, given to a measure of the linearity of a series of points on a scatter plot. Whoa, that's a lot of language. What does that mean? First thing, it is really, really important for you to note that we do not use this to decide if there is an association. It is just the value of R, this Pearson's correlation coefficient, is nothing more than a value given to how close those little kisses are to a perfect straight line. All right, and obviously, as we say here, we have these values falling between. And as we say here, we have the values falling between -1 and 1. And if you remember, -1 basically means that the kisses go in a perfect line straight down in a negative sense, and a +1 means a positive sense. For all other values, well, that meant that the crosses were getting further and further away from what we would call a perfectly straight line. Now, guys, if you haven't already done so, do me a favor and subscribe by clicking that little doohickey in the corner. Why? Well, basically, it's really important to me to know that people are actually watching these videos and that there are people subscribing. I'm never going to get rich, never going to get famous, but it's good if you can subscribe. And also, there's MaffsGuru.com, which is absolutely free to sign up to and has all of these videos organized by textbook, by chapter, and downloadable notes. Now, back to our table that we got from the Cambridge Further Maths textbook. Thank you very much, Cambridge. Basically then says that we could describe our scatter line or our scatter plot in terms of a strength, a direction, and a form. All right, and so you had strong, positive, and linear. And where do we get these values from? Well, the table that is shown. Yes, and those values of R became really important. The only other one to remember is an R value equal to 0 means basically there is no association. It's all over the place. But again, it does not mean that what is on my explanatory variable is in any way related to what is on my response variable. It is just a measure of how tight those little kisses are. And in a later video, I can tell you now that I can show an almost perfect correlation between the number of IKEA stores a country has and its number of Nobel Prize winners. All right, now to me, there is absolutely no relationship to that whatsoever. I think that's a coincidence. But anyway, too much information. Okay. But what is this value of R? How on earth are we going to find this value of R? Well, there are two ways of doing it. One, by hand, and two, using your CAS calculator. Praise be to the CAS calculator. Now, first things first, I'm going to show you how to do it by hand. Yes, it's a little bit long, it's a little bit laborious, but you never know. In a SAC or an exam, you may be asked to do some or all of the process. You do not know, and it's better to understand how to do it than just praise be the calculator. So the first thing is we need a formula, and this is a formula you're going to write in your summary book, and it seems a little bit confusing, but actually it's like a roadmap. It's going to teach you how to do this step by step by step, and I'm going to sort of zoom out just a little bit, and then I'm going to say, right, so we have this value of R, which we know is this E symbol. That's nothing more than sum. So it's telling you to sum something. And normally we sum all the things after that little E symbol. So I'm going to open a set of brackets and it says X minus X bar. Now where we have the letter X, it normally means for each individual X data value. So the X stands for the data value. What does this X bar stand for? Well, you've met it before. It means the mean. And in this situation, the mean of all the X values. So working through, X is an X data item, and X bar is the mean or average of the X data, which we can work out. Add them together, divide by how many they are. You're going to multiply that by Y minus Y bar, funnily enough. And again, you're going to take the Y values, and you're going to take away the mean of all the Y values. It says here, the Y data subtract the mean or average. And again, you could work that out. Luckily, I've done it all for you. You are going to divide by the number of data items minus 1. That's really important. I recorded this video earlier and forgot to take away the 1, had to do the whole thing again. And here is the result. And then I'm going to times it by Sx and Sy. Now what is this Sx and Sy? Well, again, Sx is the standard deviation of the X data and Sy is the standard deviation of the Y data. Okay, so that's the formula. And if we understand how to deconstruct that formula, we can use it to help us create a table to work all of this out. And that's what I'm going to do. So we have an example from Cambridge, and there we go. We've got some x values and we have some y values, and they've told me that x bar is 4, y bar is 5, sx is 2.236, and sy is 3.082. Fabulous. Thank you very much. They've given me the information. How am I going to use it? Well, if we go back and remember, we've got r was equal to e, x minus x bar, y minus y bar, divided by n minus 1, sx, sy. First thing I'm going to do is I'm going to draw a table of results. So here we go. So here's my x values and my y values, and that's what I'm going to put in. But this time I'm going to actually transpose the table and do it coming down. So I've got 1, 3, 5, 4, and 7. My y values 2, 5, 7, 2, and 9. So we've copied those in. First thing I'm going to do now is deal with this part, and I'm going to create a column that says for each x value, take away the mean of all the x values. So here we go, x minus x bar, and draw a line. So I'm going to take 1 and subtract from it x bar, which we knew from the question was 4. So 1 minus 4 gives me minus 3. I'm going to take my next x value, which is 3, and I'm going to take away from it 4, which gives me minus 1. 5 take away 4 gives me 1, 4 take away 4 gives me 0, and 7 take away 4 gives me 3. So this is just taking some numbers away. Let's move to the next part of my formula. I've got to work out all the y minus y bar values. So we're going to do y minus y bar. Let's create that table there. And so my y values in this situation were 2, and I'm going to take away my y bar value of 5. So for each of the values in my y column, I'm going to take away 5. So that's going to become minus 3, 0, 2, minus 3, and 4. What does my formula tell me to do then? Well, between those brackets is a kissy kissy. Don't worry if you don't understand what I mean by kissy kissy. It's a times. Whole range of videos on kissy kissy. We'll leave it there. So I'm now going to times the results. So I'm going to add another column, and I'm just going to put a little times in there just so that I know what I'm doing. What am I going to do? I'm timesing my x minus x bar value by my y minus y bar value. So minus 3 times minus 3 is hopefully 9. A lot of people put 6 there. No, it's 9. Minus 1 times 0 is 0. 1 times 2 is 2. 0 times minus 3 is 0. And 3 times 4 is 12. What do we do now? Yep, we keep working out from our formula. And what does our formula now tell us to do? It tells us to E all those values. So E that column, sum all that column together. Right, there we go. So bringing that down like this, adding all these together, 9, 10, 11, that gives me 23. Scrolling up just a little bit so I've got some room. What does it now tell me to do? Well, it tells me to find the value of R. I take that value, that 23, and I'm going to divide it by the number of data items minus 1. So we had how many data items? 1, 2, 3, 4, 5. So we're going to do 4 times. Now remember, it's not individual. I don't count all the x and all the y values. It's pairs in this situation. It's the pairs of data. So I've got 1, 2, 3, 4, 5 pairs of data. Take away the 1. I'm going to multiply that by s of x, which they gave me is 2.236. And I'm going to multiply that by 3.082. Now, I can't do that in my head, and unfortunately, this is where our CAS calculator comes into play. So, firing up my CAS calculator, what can we now do? Well, we're just going to type that in. So, I'm going to keyboard and fraction just to make my life a little bit easier. And so, 23, we're going to divide that by 4, multiplied by 2.236. And I'm going to multiply that by 3.082. And there we go, we get the grand value of 0.834 to 3 decimal places. Okay, so 23 divided by 4 times 2.236 multiply 3.082 gives me 0.834, and that, ladies and gentlemen, is my value of R. Yes, it feels long, doesn't it? But don't worry about it. The good news is your CAS calculator can do all this hard work for you. So minimizing that, there are instructions. If you are following the Cambridge set of textbooks, then there are wonderful examples for you in there, and perhaps there are in other textbooks as well. I don't know. But what we're going to do is I'm just going to zoom that in just a little bit, and I'm going to follow the instructions. So firing up my CAS calculator again. In this situation, we are going to go to Menu, Statistics, and lo and behold, I already have my data values in here from when I did this video before. But you will enter them in, and don't forget the X and the Y on the top of the columns, very, very important. Yes, it's going to become more and more important as we move in and through this course. So what do I do now? Well, believe it or not, I'm going to do a regression analysis. We're going to do more about this in just a few videos. But what we do is hit Calc, Regression, Linear Regression. Now, what it needs you to do then is tell you, well, what's your X values and what are your Y values? Which way do you want your data to be? Well, in this situation, my X list, so I hit on that and I go main/X. All of the variables you choose are going to be main/. So we want X. And my Y values, obviously, I want to be main Y. And when I hit OK, ladies and gentlemen, there we go. What do we get? We get my value of R, absolutely. So my value of R there is 0.834. What do we get? Let's just scroll this down, 0.834. Probably a lot easier just to put the data in and use the statistics function. Yes, I agree. You're probably wondering where they got the rest of that data from as well. Well, the great thing is if I go to Calc and to Variable and do list X as X and list Y as Y and hit OK, bang, what do you notice? Another thing came up. Now, you've done this previously, so this isn't anything new, but let's just check whether we actually agree what they say. So X bar, can you see X bar on here? Yep, 4. We got 4. Y bar down here is 5. S of X is 2.236. And if I scroll down, we can probably find S of Y of 3.082. So we can get that information from our table as well if I need to. Let's move on to a VCAR question. Now, there's not many actually in relation to this, but this one here I thought was an interesting question, not necessarily relevant to this. There is a strong positive association between a country's Human Development Index and its carbon dioxide emissions. So first things first, strong positive means it's probably going to be something along that lines. We have our Human Development Index and carbon dioxide emissions. Now, first things first, how did I know the Human Development Index went on my explanatory? A good guess, to be honest with you. It's highly unlikely that the more carbon dioxide we pump into the atmosphere, the higher or lower the Human Development Index is, all right? So if you don't know what a Human Development Index is, just Google it. Just type it in, read whatever comes up first, undoubtedly from Wikipedia, and then at least you'll have a bit of an idea what it is. So the question is, from this information, it can be concluded that increasing a country's carbon dioxide emissions will increase the Human Development Index. That makes absolutely no sense to me whatsoever. Yes? Pumping more carbon dioxide into the world probably isn't going to make anything particularly good. Decreasing a country's carbon dioxide emissions will increase. Nope, because again, we're having a positive, strong positive association. This association must be a chance occurrence and can be safely ignored. Come back to that in a moment. Countries that have a higher Human Development Index tend to have higher levels of carbon dioxide. Put in a circle around that. In pencil, I can always rub it out. Countries that have a higher development index tend to have lower levels of carbon dioxide. No. And in fact, I'm going to tell you that part C is also not an answer because that comes up in a section a little bit later on about causation. And as far as I'm concerned, part D is the correct answer. And as I say, ladies and gentlemen, that question wasn't necessarily totally relevant to this, but I didn't find a question where they particularly ask you to do the value of R. That could be a good thing, that might be a bad thing. Don't forget, your SACs, they can ask you to do anything in. And I am done. Thank you very much for watching this video. Really good to see you. Thanks for dropping by. If you haven't already done so, if you can subscribe, if you can also spread the word, that would be greatly appreciated. TikTok. I'm on TikTok, which is very weird, and Facebook and whatever social media you guys use would be greatly appreciated. Otherwise, I look forward to seeing you in our next video. Take care, stay safe, and I'll see you soon. Bye-bye.